So far we've looked at what would happen if you double the interest rate, and we looked at what would happen if you doubled the amount of time that an investment was going in for, and in both cases it more than doubles the amount of interest that you earned. In investigation 2, we're going to actually change the number of compounding periods per year. So in investigation 2, it says that Kevin's got $40,000 that he would like to invest in an RRSP for 15 years. So his principal is $4,000. We don't know what the final amount is, so we're going to try and figure out. He's going to invest it for, this is our principal, it's going to be in there for 15 years. How much will it be worth if he gets a rate of 6.5% compounded annually? Well, annually means one time per year. So if his interest rate is 0.65, that means as a decimal, that's 0.065. And it's going to be in there for 15 years. So 15 times 1 is equal to 15. So if we calculate that, 15 times 1 equals 15. So my final amount is going to be $4,000 times 1.065. So in this case, 0.065 raised to the exponent 15. So my final amount is going to be 1.065 to the exponent 15 times 4,000. So the final amount here would be $10,287.36. Okay, so that would mean that his interest, so if I subtract the $4,000 he originally paid, interest, he's going to end up with $6,287.36 in interest. Okay, so now let's change some of these conditions. Instead of compounding it annually, this time we're going to compound it quarterly. Again, quarterly means 4 times. So all other conditions are the same. So this time, his principal is still $4,000. His interest rate is still 0.65%, but now we're compounding that quarterly. So 0.065 divided by 4, that's our new I value. So 0.01625. And now it's in there for 15 years, and we're compounding it 4 times per year. So 15 times 4 is going to give us 60. So now our equation changes slightly. So let's start plugging things in. So A is equal to 4,000 times 1.01625 to the exponent 60. Okay, well, that's going to mean 1.01625 to the exponent 60 times 4,000 is going to give us a final value of $10,521.88. So if I look to see what the interest is, I subtract the original $4,000 that was invested. That means he earned $6,521.88 in interest. So if I compare that with my previous answer, he earned about $300 or so more in interest when we increase the compounding period. Okay. So let's do the same thing, and now we'll deal with it on a monthly basis. So monthly is 12 times per year. So again, trying to figure out my A value. Got 4,000 to start off with. 0.065 was so 6.5% was the interest rate, but now I'm compounding it monthly. So 0.065 divided by 12 gives me an I value of 0.00. I'll do 516. Okay. And then my N value is going to be 15 times 12. So 15 times 12, it's 180 compounding periods. Okay, so now we've increase the compounding periods. So if I plug that into my formula, I'm going to get 4,000 times 1.00516 raised to the exponent 180. So if I calculate that, we're going to see what impact that has had on the total value of the investment. So 1.00516 raised to the exponent 180 times 4,000 gives me a grand total of $10,101.73, call it. So if we just want to figure out the interest, we subtract the original $4,000 that went along with it, and that's $6,101.63. So in that situation, he actually ends up getting slightly less. Okay, which makes me wonder if I made a mistake, but I'll quickly double check that. Okay, so we've done monthly. Let's see if we can go weekly. So if we, again, plug in the same values, oh, oops, let me change the thickness there. So weekly means it's compounded 52 times. So starting amount, $4,000, 0.065 this time divided by 52. 0.065 divided by 52 is going to equal 0.00125. And the end value, 52 times 15, 780. So if I plug this in, I get 4,000 times 1.00152 raised to the exponent 780. So 1.00125 raised to the exponent 780 times 4,000 gives me $10,598.61. So his interest, if I subtract the original $4,000, the interest now is 6598.21. Okay, so if I compare that previously, okay, you continue to earn more and more interest as you go quarterly. Then as we go monthly, we're doing the same thing. So I just want to quickly verify that I've made this calculation correctly here. So 0.065 divided by 12, 0.006. Ah, this should be 6.4. I missed something. 6.416. That's why. All right, so if I redo this calculation, it will make more sense for me now. So I'm going to erase this piece. So this should be 0.005416. So that means the A value, or in brackets, me 1.005416, all raised to the exponent 180. So if I do 1.005416 raised to the exponent 180 and multiply that by 4,000, that gives me $10,575.54. So if I subtract the original $4,000 investment, it gives me 6575.54. Okay, now we're clear. So in the long and short of it, if you increase the number of compounding periods, gradually you do increase the amount of interest. Okay, so what impact does changing the frequency of the compounding value have? Well, more compounding periods equals a higher value of the investment. And similarly, less compounding periods is going to equal a lower value of the investment.